In this session, we will discuss exam style questions from the topic of sound from under the subject of O-level physics. And this book written by Duncan and Heather Kennett and published by Hodder Education. Exam style questions are available on page 174. And a girl stands 160 meter away from a high wall. This girl is about 160 meters away and claps her hand. She claps her hand here at a steady rate so that each clap coincides with the echo of one before. Her clapping rate is 60 per minute, 60 clap per minute. Calculate the value this gives for the speed of sound. So this is 160 meters. Clap her hand at a steady rate. Clap is 60 per minute, means 60 clap per minute, 1 clap per second. So she has 1 clap per second if she has 60 clap per minute. So 1 clap per second. So 2D is equal to Vt. So V is equal to 2D upon T. Distance is 160 meters, so clap reaches and then return. So T is 1 second per clap. So the speed of sound is 320 meters per second. So V can be obtained 320 meters per second. If she moves 40 meters closer to the wall, she finds the clapping rate has to be 80 per minute. She finds the clapping rate has to be 80 meters per minute. Calculate the value these measures give for the speed of sound. So D is equal to 40 meters, so it becomes 120 meters. So 120 meters means clap rate should be 80 claps per minute. So 1.33 claps per second. So 4 clap in 3 seconds basically. So the speed of sound is equal to 2D is equal to Vt. V is equal to 2D upon T. This T will be here, and this is 120 meters because she has moved 40 meters here. So this is 160 becomes 120. So 120, and this is 2 here, and this is 3 upon 4 seconds per clap. So we will divide this 240 by 0.75. This is 0.75. Multiply this 120 with this 2, it becomes 240. So this is 3 upon 4 is basically 0.75. When we divide this, we will get this 320 meters per second. Simple answer. And if he moves again and find the clapping rate becomes 30 per minute, calculate how far she is from the wall. If the wave speed of the sound is the value you found in A. So if she moves 30 becomes 30 claps. So if she moves away, then 30 claps can be get. So in that case, we have to find clap rate is 30 meters per second per minute. The speed of sound is 320 meters per second. 30 claps per minute means half clap per second. 1 clap in 2 seconds. So 2D is equal to Vt. So D is equal to Vt upon 2. So V is 320 meters per second. And this 2 is this 2. And T is basically 1 second and half clap. So this is 1 second divided by 0.5 is 2 seconds per clap. This will cancel, this will cancel, this 2 will cancel here. This speed will be 320 meters. So she should be 320 meters away. She should be double this length of this. If you double the length, then half the clamp. Sketch the waveform of a low pitch note. This is Lord and low pitch note. A soft high pitch note. A soft, a very smooth, and high pitch. The frequency is so close. High pitched means low amplitude, high frequency, high pitch. So it takes more time, but it takes very less time period. So the frequency is high, and the sound is smooth. And here we have a lot of noise. Other harmonics are there. So loud, noisy. This is a smooth one. If the speed of sound is 340 meters per second, what is the wavelength of a note of frequency 340 hertz? So this is 340 speed meters per second. Lambda, you have to find, the frequency is given 340 hertz. So V is equal to lambda upon F. So lambda is equal to V upon F. V is 340 meters per second. Frequency is 340 hertz. So on dividing this, we get this 1 meter. So the wavelength is 1 meter. For 170, same, we will get this lambda is 2 meters. So that's all from here. And in the next session, we will discuss the remaining questions of sound.